I want to give you the full picture of what waveform diagnostic with picoscope can actually cover. Because once you understand the scope of this tool, you will start seeing opportunities to use it everywhere. The first area is the electrical signals. The sensors and the actuators. This is where most people start with an oscilloscope. For example, on a GDI engine, gas direct injector, you can simultaneously capture the voltage and the current waveform of a direct injector on the same screen. The voltage waveform tells you about the controller signal, about the fault issue, and the timing, the duration. The current waveform tells you what the inject coils is actually doing. Whether the solenoid is responding correctly, whether the peak and hold current pattern is right. Together, they let you judge both the control side and the execution side of the injector in one picture. The second area is the network bus. Picoscope doesn't just show you the raw voltage waveform on the bus. I think you have some feeling about that. We just do that today. And it also can decode the bus data in real time, overlaid it directly on the waveform. So you can see the physical layer and read the actual message content at the same time. That's extremely useful for fault analysis. The third area, and I know some of you are wondering about this, is high voltage EV diagnostics. A lot of people ask me, can picoscope really be used on high voltage systems? The answer is yes, absolutely can. But you need to understand the principles and the safety requirements before you connect anything. Picoscope can capture insulation monitoring waveforms, invert switching signals, and high voltage battery behavior. Since that are invisible to a standard scan tool. We will cover this in a dedicated session because safety knowledge is non-negotiable here. Fourth is NVH, noise, vibration, harshness. By connecting an accelerometer to one of the picoscope channels, you can capture vibration data, run frequency analysis, and identify the source of the noise and the vibration that are completely invisible to a scan tool. A rattle, a knock, a road noise complaint, the oscilloscope can show you exactly which frequency it comes from and help you pinpoint the source. The fifth, engine mechanical diagnostic without disassembly. This is one of my personal favorites. Using an in-cylinder pressure transducer connect to the picoscope, you can capture the actual pressure curve inside the combustion chamber. From that single waveform, you can precisely see when the intake and exhaust valves open and close. Measure the exact crack angle, check compression cylinder by cylinder, and even identify catalytic converter blockage from the exhaust back pressure pulse. Since that traditionally required major disassembly to diagnose. In real diagnostic work, we combine these techniques together to tell the complete story of a fault event. So if we have another chance, we can share another topic to you.